Let's start chapter 13. In today's, we will continue what we start in the first section here in chapters talking about compound and aqueous solutions. In first idea, we talk about the dissociations. We explain how actually the ionic compound dissociates because the ions already exist in the crystal lattice. And then we explain what is the precipitation reaction, double displacement reactions. And then we know how to write a net ionic equation to show which is ion undergoes a chemical exchange. And we stopped at the ionizations. First, we will start our section to differentiate between the ionizations and dissociation. After that, we will classify the solutions according to conductivity of electricity in two types, electrolyte and non-electrolyte. After that, we have three categories, okay? The electrolyte could be strong or weak electrolyte, but the non-electrolyte is only one classification because it does not conduct electricity at all. So let's start first to see the first idea here, the ionization. Okay? Yes. Ionization. First, do you remember dissociations happen in what type of compound? Ionic or covalent? Ionic compound. And ionizations happen in a molecular compound or covalent compound. Ions are formed from a solute molecules by actions of the solvent in a process called ionizations. When a molecular compound is dissolved and ionized in a polar solvent, ions are formed where none exist in the undissolved compound. So this is the difference between dissociation and ionization. In dissociation, the ionic compounds already have the ions in their crystal lattice because they are ionic bonding together by the electrostatic attractions between their ions. In ionization here, the ion is forming because of the polar solvent ions are formed where none exist in the undissolved compound. We will take some example of the dissociation. So as we mentioned, first let's have a recall example of dissociation. Anyone have any example of ionic salt? Anyone? Example of ionic compound or ionic salt? NaCl. Okay. NaCl. This is stable salt, sodium chloride. When it's dissolved in water, it gives us what? Na positive plus Cl negative. Ion is already exist. So this is dissociation happen in which type of compound? Ionic compound, CBT. Yeah. This is salt, aqueous. Very good, Yamayar. Then we have ionization. Ionization. For the ionization, guys, we said that it's happened in which type of compound? Molecular compound or that covalent bonding. Actually, molecules mean they are covalent bonded, okay? For example, if we have HCl. The HCl, if you remember, guys, it's polar or non-polar compound. Here is the H, low electronegativity. Here is the Cl, high electronegativity. So there is a dipole, according to the electron negativity of the chlorine atom, pull the electron of the shared pair toward this. And this is form a partial negative charge upon the chlorine atom, a partial positive charge upon the hydrogen atom. So the polar compound, when it's dissociated in water, it gives us H positive plus Cl negative. Ion is not exist here in the molecules, but it's formed after it's dissolved, and because of the bond is breaking down because of the release of energy that when they are dissociated or ionized to form a protonium ion and a chlorine ion, aqueous solution. Remember, ionization normally happens for a strong acids and strong bases because hydrochloric is an acid, right? Stomach acid, right? So when it's ionized, it gives us what? Protonium, hydrogen, and chlorine. In reality, guys, the protonium here does not exist. actually in the solution. Why? Because it's attached to a water molecules to form H3O positive, and this is called hydronium ion. Very good. This is called hydronium ion. So all of the acid ionizations, it's forming hydronium ion because the protonium is not exist alone, because this is not decreasing the stability of the protonium. So he attached it to the water molecule to form a hydronium ion. So any ionizations, if it's there is H positive, you write it hydronium because this is what exists in the solution. Okay, let's get back to, do you understand the difference between ionization and dissociation? Okay, yeah. This is our first ideas. Okay, the hydronium ion. Some molecular compound ionize in an aqueous solutions to release H positive. The H positive ion attract other molecules or ions so strongly that it does not normally exist alone. So HCl attract the H positive attracted to H2O to form hydronium ion in aqueous solutions and chlorine. And we name the H3O hydronium ion. Now, second idea of this section, we will classify the solutions according to what conductivity of electricity to electrolyte and non-electrolyte. Do you hear this word that in everyday life, like electrolyte before, in any kind of?
Yes, it's in water.
Yes, in the gym, and the power drink, right? Yeah, like in some drinks of the sport, it's have something that's called electrolyte. What actually electrolytes mean? What do you mean? Huh?
Are substances that yield to an ion that can conduct an electric current.
Yeah, this is a chemical definition, but I want it from your general understand. Yeah, like there is a something, an ion is dissolved in this drink, right? Or dissociate, right? This is what meaning of electrolyte. So electrolyte solutions, guys, are a substance that yields ion and conduct an electrical current in the solution. The strength within which the substance conduct an electrical current is related to their ability to form ions in solutions. So what determines if this electrolyte could be a strong or weak electrolyte? How much it ionizes, how much it's forming an ions. And this is very important. So a strong and weak electrolyte differs in the degree of ionization or dissociation. This is why we study ionization, dissociation, to understand how we could actually categorize the solution according to its conductivity. So with your concept, the higher the dissociation, the more common to be strong or weak electrolyte. Strong electrolyte. The lower the solubility or the lower the ionization, the lower to be weak electrolyte, or could not be actually a non-electrolyte. Could be a non-electrolyte that actually did not form ion at all. So let's classify this as three categories: strong electrolyte, weak electrolyte, and finally the non-electrolyte. Okay, guys? So again, we will start first with strong electrolyte. We said that it depends on the degree of what? We said that ionization and dissociation. So which is ion? Actually, all of them that dissociate 100%. Like in the beginning of the lesson that we take. Ionic compound, right? Ionic compound. Ionic compound, guys, completely ionize, dissociate, right? Completely dissociate. So all of them considered as strong electrolyte. Like the example that we take, that calcium chloride, for example, ClCl2, or sodium chloride, NaCO. All of these considered as a strong electrolyte. When it's dissociated in water, it gives us ions, right? Calcium positive plus 2 chlorine ion negative, and here it gives us Na positive plus Cl negative, 2 moles of ions. Remember, ionic compounds, some of them actually insoluble. So focus on that. We talk about the soluble one, or that we have high solubility. Because if actually the ionic compound did not dissolve, that like when we studied the precipitation, it does not form any ions. Do you remember when I told you that some ion does not dissociate because it's forming a precipitate?
Yeah.
So we will consider this as an weak or strong electrolyte. Weak. So the soluble ionic compound, to be specific, dissociate. So what is the things about the dissociation? They are 100% dissociation. It means that all the salt compound converted to ions. And if we have a beaker here to represent what we found, for example, if we put the table salt here in the water, we have here sodium chloride, we put it inside the beaker here, we only find the Na positive and Cl negative. We will not find any of NaCl salt inside the solution in the beaker. Of course, it's surrounded by the water molecules. So again, what is the idea, guys? That the strong electrolyte conduct electricity well because all of their compound completely ionized, 100% converted to ions. Okay? So first, ionic compound that they are soluble. What about the molecular compound? For the molecular compound, we talk about ionization, right? So, what we search here to be a strong electrolyte, completely ionized or partially ionized? Completely ionized. So the compound in the molecular compound that make this, guys, the strong acid and the strong base. Example of a strong acid. Anyone could give me an example of a strong acid? Hydrochloric acid or sulfuric acid, HCl. It's completely ionized, right? 100 tends to be almost 100% ionized. It means that all the molecules here converted to ions. The HCl, when it's ionized, it's forming what, guys? Anyone? Hydronium. We just said that. It's not exist as a protonium. So H3 positive plus Cl negative. This is considered as a stronger weak electrolyte, strong electrolyte. Why? Because it's completely ionized. This is mean all the ions is converted to, or the molecules converted to ions. Another example like a strong acid, the H2SO4. What we name this, guys?
Sulfuric acid.
Sulfuric acid. When it's dissociate, guys, it gives us 2 ions of hydronium because it's subscripted here, plus sulfate ion, -2. Completely ionized. So again, strong electrolyte, conduct electricity well or poorly conduct electricity? Conduct electricity well. Why? Because they completely dissociate or completely ionize. And we classify under these categories the ionic compound or the strong acid and base in the molecular compound. And I told you that inside the beaker, for example, if we represent the HCl in a beaker and we have the water, do I find inside it HCl like this? Do I find HCl inside it? No, at all. But I only found hydronium ion and Cl negative, surrounded by the water molecules, of course. Do you get the idea of? Okay, now this is our first category, the strong electrolyte. Now, the second category is the weak electrolyte, guys. That what determines the strength of the conductivity of electrolyte? The degree of what? The degree of what? Dissociation and ionization. So if it's completely ionized, strong electrolyte. If it's partially ionized, weak electrolyte. So here we have in the weak electrolyte ionic compound also. But guys, could one determine what I will write here? Perfect theta. Perfect theta. Insoluble. Or they have low solubility. Anyone have an example from the table that we take it in the previous? Any example that forming a precipitate? We have a general guideline. Huh?
Sodium.
Sorry. Sulfide salts or chloride, all of them are soluble except for what? Except for
strontium, sodium, potassium, and ammonium.
chloride. For the chloride salts, all of them are soluble except for perfect يا معيار. Silver chloride is insoluble, right? And mercury. So silver chloride is an example of a weak electrolyte, AgCl. Why it's a weak electrolyte, guys? Because partially ionized, or its ionization to forming ion very, very low, considered to be 0.1% of ionization. So this is also will form an ion, but actually, guys, this is ion actually very, very low ions, and you see that most of the directions here forming an ion, it's very low, that 0.1%. So we have here the ionic compound that unsoluble. Also, lead. What about the lead chloride? As we consider it, lead chloride. Okay. So do you get it? Okay. What about ammonium sulfide, NH4S? Go to the table and see it. Page 420. Really? All the ammonium ion are soluble. So do not consider as.
So yes, it's not considered as.
So what type of sulfide that? What about cadmium sulfide? Cadmium sulfide, insoluble. Perfect, ya Muhammad. So this is considered as what? Weak electrolyte. Because they not form ions, or they are very little ion that form. Okay, Aidi? Okay, so first ionic compound that are insoluble or have low solubility. Another thing we took in the strong electrolyte, we talk about strong acid and strong base. Here we will talk about weak acid for the molecular compound. Weak acid and base. An example of weak acid, hydrofluoric acid, HF. When it's ionized, do you observe what actually, how do I write the arrows here? If you get back to the strong electrolyte, do you see that it's one directions arrow? It's yield, all the compound is converted directly. One directions, all of them 100% ionized. But here, as you see here, for the weak acid, there is an equilibrium state here because not all the ions converted to it. So it's forming what? Forming what, guys? Hydronium and fluorine. Fluorine ion. Weak acid and base. Okay? Okay, guys? So here is an example of a weak acid. If we measure the concentration, guys, of hydrofluoric acid in the beaker, we will find that it's greater than the concentration of the hydronium ion also and the concentration of fluorine ion together. The bracket here represents the concentration. If we go to the beaker here, guys, could anyone tell me what type of ion I will find it inside it? Anyone?
You will find hydronium and.
We will find hydronium, right?
And
A fluorine ion and hydrofluoric acid inside it. Because it's not completely ionized, so you will find all the molecules here exist in the beaker because actually it's partially ionized. It tended to be 0.1% of ionization, very little. So this is will conduct electricity, or poorly conduct the electricity. Poorly conduct the electricity because it's not contain much ions. As we said, the most important factor to determine the strength of the electrolyte, the degree of ionization or dissociation. So I understand the second category, weak electrolyte. Now to the last one. the non-electrolyte. 3. Non-electrolyte. So, guys, what do you think about the non-electrolyte? Does actually it's form ions? Not forming ions. Not forming any ions. Do not dissociate, do not ionize. Anyone have an example that we talk about in the previous chapters when we talk about the solubility of some substances? Do you remember substance when it's dissolved, it do not form any ions? Huh?
Oil.
Something that we use every day in our teas and sugar, sucrose. If you dissolve some type of sugar like C12, this color is not. The sucrose, guys, C12, H22, O11. When it's dissociated in water, it just is converted to an aqueous solution and keep as it is as a non-polar compound that actually do not form an ion. Do you find any ions here? Okay, so we have the sucrose. Also the glucose, guys, C6H12O6. When it's dissociated in water, it do not form any ion because he actually non-polar compound do not dissolve most of the hydrocarbon, so forming the glucose and sucrose an example of non-electrolyte. Why they are non-electrolyte, guys? They do not form any ions. Another example of a non-electrolyte solution, the alcohol, like methanol. Okay, guys, CH3OH, or like ethanol, C2H5OH. When it's dissociated in water, it just converted to an aqueous solution. Do not form any ions. Also here for the ethanol, C2H5OH, aqueous. So normally here in non-electrolyte that do not form any ions, like so the non-electrolyte does it conduct electricity well or poorly, or do not conduct electricity at all? Do not conduct electricity at all. So let's summarize all the idea that we mentioned. We talk about dissociations, we talk about ionization, how they form a hydronium ion. Then we differentiate between dissociation and ionization. It's happen in dissociation happen in what? Ionic compound. Ionizations happen in what? Covalent bonded compound. Then we classify the solutions according to the degree of ionization or dissociation in 3 types, 3 categories. Electrolyte, strong electrolyte, weak electrolyte,
and
non-electrolyte. Strong electrolyte conduct electricity well because it's completely ionized, completely tends to be almost 100%. The weak electrolyte conduct electricity poorly because they're not completely ionized, like the insoluble ionic compound or weak acid and bases. And finally, the non-electrolyte do not form ions at all. Let's get back to the slides here to see what we mentioned, to see that in actual beaker. This is, guys, here an example of dissociation, as I told you that. As you see here in the sodium chloride, the strong or weak electrolyte, sodium chloride, strong electrolyte because it's completely ionized, and you could see that you could not find any NaCl as a solid substances or an aqueous as a molecules. It's just the ions of chlorine, the ions of sodium surrounded by the water. Here we have the weak electrolyte, the hydrofluoric acid, because it's weak acid. You will find the fluorine ion, the hydrofluoric acid, the hydronium ion, all of them surrounded by the water, not completely ionized. Here you have the AgCl. We know that it's insoluble. Do you see that most of the compound here, AgCl, is found down in the bottom of the beaker? Do you see that? The salt is actually precipitate. You could find several ions with very low degree of dissociation. So that's considered as a weak electrolyte. Here we have the sucrose, they're not forming any ions at all, and you could see that the water molecule attached to the sucrose by the hydrogen bonding, so it could be soluble, but actually they're not form any ions. So this is considered as non-electrolyte and do not conduct electricity at all. So as we mentioned, strong electrolyte, any compound whose diluted aqueous solutions conduct electricity well. This is due to the presence of all or almost all of the dissolved compound in the form of ions. Sorry. To whatever extent they dissolve in water, they yield only ions like HCl, HBr, HI, all of them strong acids, or all solutions in ionic compound that are soluble. A weak electrolyte is any compound whose diluted aqueous solution conduct electricity poorly. This is due to the presence of a small amount of the dissolved compound in the form of ions. Some molecular compounds form aqueous solution that contain not only dissolved ion but also some dissolved molecules that are not ionized. For example, the hydrofluoric acid, as you see that there is a state of equilibrium here between the ionizations and the ions that combine together again to form the acid. So the concentration, as you see, of hydrofluoric acid is higher than both of the ions. And finally, the non-electrolyte do not conduct electricity at all because it does not form ions. Do you have any questions? Guys? Sure?
Yeah.
You understand it all?
Yes.
Okay. Thank you.